120 years of heavier-than-air flight, aircraft have evolved from a dangerous curiosity to a multi-billion-dollar global industry, and a couple of factors have always been true. Airframe development has been constrained by the pacing element of power plants. Gas turbines were a logical evolution from piston engines for aircraft use, and today, electric propulsion is evolving due to higher energy density, lighter weight battery systems. Both internal combustion engines and battery electric drive have distinct advantages, but neither has the full spectrum of range endurance, low noise, and low emissions that would define a perfect airplane. Could a hybrid approach that combines the best of both into one airframe be the answer? Well, that's a design challenge. I had a very interesting roundtable discussion with two industry experts who claim not only that it's possible, but that it's on the way. Take a look. Roberto, you cover aerospace from the perspective of some very large airframers as well as startups. This feels to me like a new age in aerospace. What are you seeing in the industry? Is the Volterra experience, is this typical of what we're going to see for the next 10, 20 years going forward?
Yeah, so you're totally right, Jim. We saw a boom in new companies emerging from the ground up. So we call them the shakers, because they were able to shake the industry. It's applicable for the aerospace, but also in new space. So if you can disrupt new space, you can disrupt everything. And so coming back to commercial aviation, yeah, I think it's really the technology that has evolved, especially on electrification. And so when you bring in electrification, you can have more freedom to design very novel configuration of aircraft. If it's distributed propulsion, if it's blended wings, if you want to also to work on laminar flow. So those are capabilities or possibilities that electrification brings. It comes also with difficulties, as Michael said, about the range and how to mature those technologies. So right now we are eager to see those technologies being certified maybe this year.
If you're a company making very large airframes in Seattle, in Renton, or in Toulouse, you have access to a huge pool of engineering talent. So you'll have an expert on flap tracks, and you'll have an engineering expert on land nose wheel assemblies, and one on APUs, and you have this huge sort of institutional knowledge you can draw on. When you're a smaller firm, you can't possibly have an endless number of engineers to do this. Is this cloud virtual system, does this give you any advantages now and be able to reach out and find engineers that have specific expertise you need?
Yes, because it's easy to give them access to our platform, and if we want, we can give us a restricted access to just for one assembly. But if they need to have all the aircraft to check the interfaces, we can give us a read access to the rest of the configuration. So it's really easy to manage access, credentials, collaborative space, and organizations between. For example, in one team, we can separate the organizations for one user and another, and they can check. They can have read access on each systems or assembly, but they can't modify them the other assembly. So we can manage what we want.
So it comes up frequently, this notion of perhaps your supplier of flap actuators, screw jacks, he would like to see the whole wing design to understand how his component fits in. But of course, you would not necessarily want to give them that level of access. You'd like to give them access of just the flap track and the mounting area for that component, and that's possible.
Yeah.
When there's a domain that requires significant investment in terms of tool knowledge, we have developed something called virtual twin as a service, where the customer would bring in their data and their use case, and the system would do it for them with all the knowledge that we have in-house. And so we deliver the results to you.